All right, so we left off on the other one there. We were working with this example one, find the length of arc S there. Noticing your arc S here is on the outside, so we're actually trying to find this one here on the outside. So since this is 120 degrees in here, we really wanted to go ahead, and since there's 360 all the way around, we want to take 360 minus 120 there, which gives us 240. And I was finding it of that 100. I was trying to find it of the angle in here rather than the 240 here on the outside here. So let's go ahead and do it this other way here. So we can go ahead and find that arc length there on the outside here. So we can end up taking um, our value here ends up being 240 times over 180. And again, you can look on your unit circle for these. So when I end up changing this ends up being 4 pi over 3 because I get 240 pi over 180 there, and I can divide them both by 60. So really I'm going to put in here 4 pi over 3. This ends up being 28 pi over 3. And so when I end up doing my math on this, I end up getting about 29.3. So, and then part D here says find the arc of the length that subtends a central angle of 30 degrees. So I'm going to kind of draw a little picture here. This is my 30 degrees. That's theta. And the radius there, they're telling us 3 miles. Central angle there is 30 degrees. So I'm going to put them all in here. This time we're going to have units that we're going to label something as, and we're supposed to find the length of an arc. So we have a formula for that. Length of the arc is S equals R times theta. Theta is not in radians, so you could either look on your unit circle there, or you can convert. So I can do 30 times pi over 180, or look on my unit circle and get this value. So I get 30 pi over 180, which gives me pi over 6, which is exactly what you'd find on the unit circle. So now plugging those in here, S equals 3 miles times pi over 6. So multiplying across, I get 3 pi over 6. Reducing that down, I get pi over 2, which then, dividing that out, I get about 1.6 miles. Again, it's not drawn to scale, so it's going to look a little different, but there's our value for that. So sometimes you have to find other parts here. So in this case, we have to go ahead and find degrees here. So let's find some degrees this time. So using that same formula we've been using, we've given here, we've got an arc length here. So we've got S this time, and we've got R this time, and this time we want to find theta. So we've got a nice formula. Arc length there is 14, R there is 6, and we want to find theta. So when we find our answer here, it's going to be in degree, or going to be in radians, and then we're going to have to convert it into degrees. So then theta equals, reducing that down, I get 7/3. So I can divide them both by 2 there, and I get 7/3. So now I got to convert 7/3 there into degrees, because it says up there to go ahead and you want it in degrees. So this is converting this here. We're going to end up getting 180 is going to come down here, and we want pi up here. So then we can simply multiply across here. This is upside down, because theta there is in radians. So it's like this is in radians, and we got to put radians down here. So it's kind of like this is in radians, this is in radians. So then the radians there will cancel out. So we can multiply across 7 times 180 and then divide by 3 pi. And when you do that, we end up getting about 133.7 degrees. And for our next one here, we can do the same thing here. Again, follow your formula. This is your 7 is your arc length. 4 here's your radius. Plug your numbers in there. So arc length is 7, radius is 4. Trying to find theta, so we're going to find it in radians. So theta equals 7/4 radians. And so now I got to convert that. Some people make the mistake here. They think that pi represents radians there. It doesn't have to have a pi in it in order to be radians. It's just 7/4 there is the number of radians, pi radians. So I'm going to convert this 7/4 radians. So that means 180 degrees over pi's and radians. So these guys cancel out. So now I can take 7 times 180, divide by 4 pi there, and we end up getting the number of degrees there ends up being about 100.3 degrees. So that's using that nice formula. And then we're going to do one of these as well, where you got a subtends the angle. It helps to draw a picture out here. So you've got a central angle here of theta. The radius here is 2, and it's in meters. And the arc length is out here. It says it's 12 meters. And we're supposed to find the measure of theta. So it helps to sometimes draw out a picture there. And they gave you arc length of, radius of, pretty simple. And then we're supposed to find theta in degrees and radians. So this time we need to find both pieces. So S equals R times theta. No different from what formula we've been using. Plug your numbers in there. Divide by 2, and so theta ends up being 6. So theta is 6 radians. So we got that portion. Now we got to convert it into degrees. So I can take my 6 radians, and I can do 180 over pi radians. And I can multiply 6 times 180, divide by pi there. Will end up giving me my degrees there, which ends up being 343.8 degrees. So there's my degrees, there's my radians. I answered the 2 questions. So sometimes you're given other parts here. So this time we're looking for the radius of the circle. And we'll just do one example because it's going to just repeat itself here. So this one here says theta is in 2 radians. Notice it doesn't have a pi thing in there this time. Like I said, it doesn't always have to have that. So using my nice formula that we've been using all along, we have S equals R times theta. Theta is 2 radians, so since theta has to be in radians, we're going to put it in there. We have our radius there. We don't have the radius, we have the arc length there being 10, so I'm going to plug that in as well. We're trying to find the radius. I guess I'll get rid of the label there, but I wanted to see that that was in all radians already. Divide by 2, and R there is 5. So part B is just similar, just using that formula. And this is the same type of problem. And we're not going to do U-turns, although you can try them out if you want. I'm going to go to example 4. Example 4 here. It says find the area of the shaded sector of the circle here. So let's go ahead and find the area of that. To find the area of that piece there, we could just go ahead and set up our formula. We found that on the first slide there. We said that it was 1/2 r squared theta. And let me go back to that. Remind you what that looks like. So remember we derived that 1/2 theta r squared. So that's exactly what we're going to be using in this problem here. There. So find the area of a sector of a circle. It's just a portion of the circle. So this is how we generated this formula here. And again, theta has to be in radians. So we got to go ahead and convert that. So I'm going to do that. 135 degrees. Since degrees is up, I got to put degrees down here. And then the degrees will cancel out. So I get 135 I over 180, Or again, if 135 is on the unit circle there, which it is, we could just look on the unit circle there and get those in radians. So it ends up being 3 pi over 4. So now I can just plug it in there. 1/2 r there is 14. I can square it and I can multiply that by 3 pi over 4. So my area of that sector of that circle, once I plug it in there, I end up getting about 9.77. And since it's area, it's going to be square meters. So that's how you would solve one like that. So let's do another one down here. We got find the area of a sector of a circle with a central angle of 60 if the radius is 3 meters. So same thing. Area is equal to 1/2 r squared theta. So 60 degrees, I can convert that. So theta is equal to 60. And degrees is up here. I got to put degrees down here. And I can 60 pi over 180. Reduce that down, and I get pi over 3. So really, I'm just going to plug in here for theta. I'm going to plug in pi over 3. And this is 3 squared times pi over 3. So when you multiply this, this is becomes 9 times pi there. And then the numerators there becomes 6. And then you can just go ahead and divide that out there, and you get about 4.71 square meters. So your homework, we're going to be working in class tomorrow, or else if you got time tonight, you could do it too. It's going to be 475, numbers 49 through 62, but I'll give you time in class to work on that. But if you want to go ahead and do that, we're also going to cover 2-7 tomorrow as well. So have at that.